In this video, we're going to talk about solving linear and quadratic inequalities of systems of inequality systems graphically. So we're going to be using a graph on these questions. All right. So the first example is just going to be two lines that we're going to compare the inequalities, but both are going to be linear. So to do this, I need to graph both lines. So I'm going to graph this line in red. So to graph y equals, y is less than x plus 2, I'm going to graph the line y equals x plus 2. So I have a y-intercept at 2, and I have a slope of 1. So I have a slope of 1. And now I have to determine, is it a solid line or a dotted line? And we use, for these, dotted, for these, solid. So if you look at the one I'm doing in red, it's just y is less than x plus 2, so we're going to have just a dashed line. Doesn't need to be beautiful. So it's a dashed line. And if I want to know where's the graph, where is y less than that line? Are the y, we have to determine, are the y values smaller below a line or above the line? And hopefully we know that the numbers are smaller below the line. So we shade below the line. Let's make that a little less obnoxious. Okay, so we shade below the line. I'm going to do the other line in blue. But in order to graph this, I need y to be by itself. So we need to move this over. So it's y is greater than or equal to negative 2x minus 4. And again, we just need to be in y equals mx plus b. So just move that 2x over. So I have a y-intercept at negative 4. And then a slope of negative 2. So I'm going to go down 2 over 1. And since there's a line underneath my inequality, we are going to actually connect the dots in a solid line. I should have put arrows on the line. And then the second line says, where is y greater than negative 2x minus 4? So I want to know, when is my graph above the blue line? So I'm going to shade above the blue line. And since it's asking me to solve, we are looking, where do the red shading and blue shading overlap? And that is right here. So the solutions to these inequalities is any x value in that region that I just or any xy coordinate in that region that I just highlighted. So we graphed the first line, y is less than x plus 2, which I graphed in red. And we're going to shade below that line because it's y is less than x plus 2. Then we graphed y is greater than or equal to negative 2x minus 4. And since it's y is greater than negative 2x minus 4, we shaded above the blue line. And then what I highlighted, the actual solution set to inequalities, is where the shading overlaps. So where you double shaded, if that's what you want to think about. And that occurs in that giant yellow region that I highlighted. All right, so I can't make it too easy on you. So we're also going to do a linear quadratic system, which the only difference is one of them will be a parabola. So first I'm going to graph y equals x squared minus 7. And I'll graph that in blue. So I have a y-intercept of negative 7. And then a quadratic doesn't have a slope like a line. So it's going to take a tad bit longer to graph. But to do that, we're just going to plug in a number a couple away from the vertex on each side. So I'm going to plug in 1 into the equation. So y equals x squared minus 7. So if I plug in 1, I get negative 6. So I'm going to have a point at 1, negative 6. That means I'm also going to have a point at negative 1, negative 6. And then if I plug in 2, I get negative 3. So there's a point at 2, negative 3, and negative 2, negative 3. Then if I plug in 3, I get 2. So there's going to be a point at negative 3, 2, and 3, 2. And that's good enough. So there I have my parabola in blue. And I want to know where is the inequality less than the line. And this is where it's going to get a little hectic. But the y values with a parabola, you're looking, are they greater inside the u? So if we pictured the parabola as a cup, if I wanted to know where the smaller y values are, would I fill up the cup or would I fill outside the cup? And if you look at my vertex at 0, negative 7, if I want to know where the y value is less than the vertex, it would be outside the parabola. Not inside, it would be outside. Because inside the graph I have the y values of 6, negative 5, negative 4, negative 3, negative 2, and then positive 7, 8, 9. But these negatives at the bottom, that's covered up by a Doceri desktop trial, are actually smaller. So we're going to shade outside the parabola. Okay? So we have all that stuff in blue. Then I need to graph my line, which I'll do in red. And my line is negative 2x plus 3. So I have a y-intercept at 3 and a slope of negative 2. And since there's no line underneath my inequality, we're going to do a dashed line here. And I want to know where is y greater than the red line. So we're going to shade above the red line. And then again, my solution to the inequality is where did we double shade, which is right there. So this is the last example. So when we are solving systems graphically, or solving inequalities graphically, you graph the first inequality, which will involve shading. We graph the second inequality, which will also involve shading. And then after we shade both of them, the solution part to the system of inequalities is where we double shade it.